get things wrong. And I just like to point this out. If you write an array, like at distances, and put the type name array before it, that isn't saying what you probably think it is. All of the type names that you write before containers in Perl 6 tell you what you're going to get back if you grab the value from it. In the case of a scalar, then you're just going to get the type of thing in the scalar. If it's an array, though, it's actually the type of the elements, the same for a hash. And actually, if you put an ampersand there for a subroutine, then you're actually saying, I want to restrict based upon what the sub is going to return, the type it declares itself as returning. So, yeah, if you're writing array distances, you probably don't want to be, unless you explicitly want an array that declared itself as being an array of arrays. And I should just add again, this isn't a dynamic check. It isn't going to go through this list and say, are they all integers? If the list wasn't declared as a list of int explicitly, that's going to fail. So I've talked about these types so far as being constraining things and doing checks for you. That isn't really the primary reason that we added types into Perl 6. Actually, this is a much, much bigger reason, multiple dispatch. In multi-dispatch, you can write multiple subs or methods with the same name. Then when you call them and you pass some arguments, it looks at the arguments, it looks at what we call the candidates, that is the different subroutines with that name, and it says, which is going to be the best one? And it picks the best match, and it calls it. So there's a few ways that we can differentiate candidates. One of them is by what we call arity. That's the number of arguments that we've passed. This example is taken straight from test.pm in Rikudo. And you can see here that I have this to-do sub, and in one case I take a reason, and in the other one I take a reason and a count. And depending on if we pass one parameter or two parameters, we're going to end up calling the correct one of these. Now, you could also have done this with an optional parameter, but it's done as multi-dispatch in the test suite. Now, you could also do dispatch by type. So this is a chunk of code from a JSON emitter written by Moritz, who's here somewhere. Oh, hi. So this is just a bunch of multi-subs which know how to turn various things into JSON. And it essentially is you can see it recursively calling itself here and over here. And each time it sort of goes through and goes deeper into this data structure. And these are the two candidates that know what to do if they encounter an array or they encounter a hash. And in the array case, we just emit JSON for the array, and then we just call down to all the things in it and the hash one. And when we actually call to JSON, these are all the candidates. There's lots more of them. It actually just picks the best one by data structure. So you can actually walk down the data structure using a bunch of multi-candidates like this. Now, we can also do constraint-based dispatch. And this is where things get really good fun, because in many cases you can say, what do I know about the problem? And then you can just write those things out. To give you an example, factorial. What do we know about factorial? We know that factorial of 0 is 1. And we know that otherwise factorial of n is n times factorial of n minus 1. How do we write that in Perl 6? Just like that.
Wow, maybe you do.
Yeah, okay. This is what, yeah, okay, there's more than one way to do it. So, why does this actually work? Why would we not call this second variant with $n? Because clearly 0 will match that. And the answer is that the multi-dispatcher actually picks the most specific candidate it can. 0 is an exact value, $n could just be anything. And actually, when you write something like this, it's really syntactic sugar. And it's syntactic sugar for that. We actually look at the literal, look at the type of the literal, and essentially inference the type, and then stick a where in. And actually, this compiles down to exactly the same as that longer version would.
Did you point out the word essentially is the smart hash?
Yeah, okay, I should have added that. Where, yeah, if what you put on the right hand of where is just smart matched against the value. In fact, all type checky things are done in smart match. So, but yeah. And we can do Fibonacci in exactly the same way. Just like that. Now, of course, we all know that writing Fibonacci recursively might be very nice in theory, but actually, when you start writing any big number in there, it's going to take absolutely forever. So do it with the series operator instead, which is much, much nicer. But the nice thing is that we can actually go from a definition to a working program with hardly any changes. So we've kind of won a lot of functional programming-y style ideas here. So now we'll go on to the slightly terrifying nested signatures. Now these are really great, but before I talk about them, I just want to introduce a couple of concepts. So we have two things in Perl 6 that are involved in actually making a call. And the important thing to realize is that these are both conceptually actually full-blown introspectable objects, which we sort of cheat and optimize away a little bit when we can. So when you actually write this here, it's a signature. And we actually build a signature object which represents everything we know about the parameters and the constraints on them and so forth. The other side of the story is that this here is a capture. So this thing down the bottom here says which arguments we're actually passing. And the signature binder's job is simply to take a capture, take a signature, and take the stuff out of the capture and put it into the variables that the signature says that the data belongs in, along with doing the checks. Now, you can actually take various other things and coerce them into a capture. So if I take an array and coerce it into a capture, it's like the elements of the array are just positional arguments. If I do it with a hash, it's like the hash pairs are named arguments. And if I actually take any arbitrary object, it goes and looks at the object, uses introspection to say what are the various public attributes on this object, as in attributes that have an accessor defined, and then it actually will treat them as if they were a hash as well. So you can coerce pretty much anything into a capture. Why would you want to do this? Well, because once something is a capture, you can match it against a signature. And we have some wonderful syntax in Perl 6 which lets us not just write a signature, but it lets us write signatures inside signatures as well. So you can say, I want to take a parameter, and then I'd like to match the parameter itself by coercing it to a capture and matching it against this other signature. Now, if you write these square brackets here, and you'll notice we have both the parentheses and then we have a square bracket inside it. What I can actually say here is I'd like to take an array parameter, and then I'd like to actually unpack it and take the first element into $head and all of the rest of them into tail. So you can actually just extract the head of the list, kind of functional programming style, like that. You can do a very similar thing with hashes. So if you are being passed a hash that you expect is going to have various keys, so here we have this %info hash, I can actually go and just unpack things in the hash. And you'll note that this nested parenthesis form is actually the kind of standard form. So I could have used the parentheses in this example as well. The only difference is that it actually checks you're passing a list when you use this form. That's the only difference. So here, I'm actually taking this hash, when I pass it in here, it's getting coerced into a capture, and then I'm matching this nested signature against it. So I can actually say, oh, I care about the name key, the lat key, and the long key, but I'd like to leave all the rest of the things that might be passed in this %rest hash. And then I can just use those values and then just go through the %rest hash later on. So we can actually pull stuff out of hashes too. And doing it to an object looks just the same. So here in Perl 6 we have a rat type, which represents a rational number. And it has .numerator and .denominator methods. So what I can do here is I can, in my signature, say, I want to coerce this thing to a rat. So it's going to do that. After it's done that, it's then going to coerce that object into a capture and pull out the numerator and the denominator part, just like that. And you'll note that the reason this kind of works is because rats, when you print them, don't actually print as something slash something. They print as just the kind of numeric value. So there we can actually pull things out of an object just using the syntax as well. So here gets really beautiful. What happens if I combine unpacking and multi-dispatch? And the answer is that we can then actually multiple dispatch by considering the sort of shape and the stuff inside a data structure. And the really cute example of this is quicksort. So this is another example where we can say, what do we know about the algorithm? And then we can just write it out. So here's our base case. We know that if we have an empty list, so this here is going to take an array, and it's only going to match when there's absolutely no elements in the array. And in that case, we just want to return an empty list. What if the list isn't empty? Well, we're going to take the first thing in the list as our pivot, and then we're going to just take all of the rest of the things into this at rest. So now we have our pivot, and we want to partition. Well, that's nice and easy. We just have a before array and an after array, and we grep. This star syntax here, remember I mentioned the star.foo, which makes a closure? Well, if you use star operator and then whatever, it actually makes a closure here. So this is like $_ less than $pivot, but closurized and passed to grep. But it's kind of cute. We call this auto-currying. And actually, if you have some expression like star plus star times 2, it'll actually build you a closure that takes 2 arguments and does all of the multiplication and stuff. So now we have our partitions. What do we do now? We just quicksort each of them and put the pivot in the middle. And that's a complete quicksort implementation in Perl 6.
Ooh.
Yeah. So this. Not if you were it in Recruiter. So, introspection. So I talked about signatures being first-class objects, and I really meant it. So if I take a subroutine that I gave as an example earlier, then I can actually get a reference to it. If you just put and in front of a subroutine name, it doesn't call it, it just gets you the object. And then I can call .signature on it, and that gets me the signature object. And one of the things that you can do with a signature object is called .params, which gives you a list of the parameter objects, and then you can just loop over them. So I can actually output here, I have a parameter $name of type whatever. And this is really nice because it actually lets you look at the signature, and you can imagine doing all kinds of things with this, like making automatic fuzzing things by looking at the signature and injecting stuff with the correct type. One of the other things that we do with it, I have a product called Zavalai, which is the Slovak imperative for call, and this is a native calling interface for Perl 6. And this isn't just proof of concept. We actually have written the Perl 6 mini DBI implementation in terms of this. And the nice thing here is that we can actually just write a sub. We write it with the name of the library we want to call, of the function in a C library that we want to call. We specify a bunch of types. So we say, here we have a string, a string, a string, a string, int, and so on. We say what it's going to return. In this case, it's just some pointer. And then we just say, instead of leaving it there, we say is native. And this thing here is a trait. And we can actually define our own traits. So this native call library provides this native trait. It then gets invoked as we are compiling this.